and happy new month to you. Hello, can anybody hear me?
Really?
Yes, we can hear you
Hello, can anybody hear me?
loud and clear.
Can hear you.
Hello? You are loud and clear. We can hear you.
Good evening, everyone. Can you guys hear me?
Good evening, sir. I can hear you.
Can you guys hear me?
I can hear you.
All right. I don't know why my phone is refusing to connect to my headset, but good evening, everyone. It's a pleasure having you guys here. So today's class is not going to be long. um, I gave you guys an assignment during the last class. How many of you did it? You can signify by, I think you can raise your hand here. Um, can you? Yeah, you should be able to raise your hand in this app. Or just type in the chat some if you did your assignment. It's very important, guys. Okay, if even if you did not do it, just um. So how many of you guys did the assignments? If you did not do it, I did not do it. If you did it, yes, I did it. And it's very important because we are going to recap and wrap things
Yes.
up on the basics of blockchain
I
development today.
unfortunately I could not do mine.
Is someone saying something? Come on now, guys. Let's use the chat box. All right. Good one. Who else? Let me see. Let me see. Okay, only Raymond has signified. What about GameFi Queen, Abu Nash, Neo Travolta? Come on, guys. This is not secondary school or university or something. No one is coming after you with a stick or something. You're probably in your house doing something. No course is being
Sorry,
taken. I
sir.
just want to
Sorry.
see. All
Sorry.
right.
Can you hear me?
Yeah, I can
The
hear you.
assignment was it the previous one on hashing, right?
Yes, exactly. The one on Ashi.
Yeah, I did mine.
Okay, you did yours.
Yes.
Can you? I don't know if you can send it to the Telegram channel if that's possible. Just send it there.
It's already there.
Oh, can you please document from Puka? Oh, just tag me to it. I can see someone's assignment here already, but I'm not sure. Okay, from New Travolta.
Yeah,
Ah,
yeah. I submitted it to Ebuka because my Telegram was bound.
okay, you are the one talking. Oh, okay. I've seen it.
Okay, something
So
like that. Thank you.
I think you are the only one that has done it, right? So who else? If you did not do it, just say I did not do it. It's very important because I need to know the extent of the revision I need to do with you guys. Mm, where is this? Okay. Okay, so only Neo Travolta so far. Eh? Okay, so let's get the class engaged. So I would call your names now. So far you tell me what you've understood in the class. You've covered a lot of concepts that is going to live with you for long, even if you whether or not you decide to become a dev or you want to be a trader or whatever you want to. These are like fundamental concepts. Okay, so just tell me anybody what you know so far on let me see one of the concepts we've covered on blockchain as a distributed ledger. What do you understand by it? um Abunash, I like to hear your understanding of that on that.
Please, if you can mention the question again. I was responding to Kelsey.
Okay, I said what do you understand by blockchain as a distributed ledger technology?
Actually, blockchain as a distributed ledger technology is an advanced way of ensuring the high level of security in the web space so that hackers cannot easily take down a particular website or a workspace. That is by distributing the information to a lot of computers. Yes,
Mm.
so basically security wise is the reason for
All right,
blockchain.
I've gotten the point I want to get from there. Basically distributing the state of blockchain to multiple different computer. Yes, so that's basically it. You don't need to explain much. Just to understand whether or not you just have an idea on what it is and what it is not. So I think the next concepts that we covered, we discussed so much. I can't even pick one to talk about here. Okay. Yeah, okay, so Neo Travolta, let's quickly go to that. You wrote on hash functions and hashing algorithm. So what do you understand by hashing in blockchain? Like what is it doing first? What is it doing? You don't need to explain technically. You've done that in your assignment already. So like what do you understand? Why do we need hashing and what is it doing? What's it there for? Can blockchain live without hashing? And those are the important questions.
Uh, hashing is hashing is a means of securing information on the blockchain, making it immutable regardless of the state of the blockchain. And the blockchain technology without hashing will be very vulnerable to to so many hacks, something like that. Uh, and the function of hashing is there are too much to mention. At one, hashing can secure the state of the blockchain, making it tamper-proof. Two, I record this. Two, sorry. Hashing helps to encrypt data regardless of the computer and regardless of the state of the blockchain. When any data that is being deployed on the machine, you get you will get you will get the same hash. I don't know how to put all these languages. Can you hear me, sir? Hello.
Um,
Hello. Can you hear me?
yes, I can hear you perfectly.
Okay. I think I can let me stop here for now, sir.
Why is everybody talking? Mm, okay, okay. So while we are waiting on Neo Travolta, let me see. GameFi Queen, what do you understand? What's your understanding of the blockchain generally? As regards blocks, the idea of chains of blocks, and all of those concepts in between. What do you understand by it? And if you were to explain it to a 6-year old, like how would you explain the blockchain to a 6-year old? Or basically, what's your understanding of the blockchain? Forget about the 6-year old. I want to hear your voice. This is just like a review class and stuff. Is someone is Deepa Empress on this call? I can see your message. Um, is Gamify Queen there also? Mm, this is for who asked that for the person who asked that question. This is like a review class. I've taught a lot, and I'm sure your other tutors have done same also. The organizers want you guys to have a test very soon, so I just need to be sure you guys understand the concepts that we covered. Yeah, so that's what's going on. So that's what's up. All right, so GameFi Queen, are you there, or are you still playing games? You guys are not talking. This is supposed to be an interactive class. Come on. Okay, who wants to step in? Um Chukwuebuka,
Good
would you
evening.
all right. Someone
Sorry, what's the question? I was in a noisy place. I didn't get it.
okay, yeah, the question is basically you just explain what you understand by blocks, uh chains of blocks, basically like the blockchain architecture, in its simplest form. What do you understand by it?
So, when you talk about blocks, chains of blocks, it's just like if I should have, let me say, first off, let's start looking at what is a block. A block is the simplest unit of a blockchain. That means it is that unit that has all the information contained in a particular section of a blockchain. Now, what is this block all about? It's just like a part of a a part of a record, a part of a record. So why is this part very important? It's very important because it contains information that we need in this record. Now, this information can be in form of a transaction information or transfer of ownership information or anything like that. So, why we call it a chain of block is that the information found in block A is related to an information found in block B, and this is only made possible because of the hashes. So part of the hash in this block A is also found in block B. So if you change
Did you
anything
say
in block
part?
A,
Sorry, did you say part of the ash? Maybe I didn't get
sorry,
that correct. Did you say part of the ash?
I said no. I said yes, yes. Like if you are checking the hash itself, the previous not part of all the hash. Like if it's block A now, if block A is starting, it has only one hash. Then if it's block B that is continuing after A, it has the previous hash that is from block A and its own new hash. You get so that continues that way. So if you should tamper with A, it will affect B because the previous hash found in B is actually the current hash in A. So when you tamper with A, it affects B, and when you tamper with B, it affects C, the subsequent block. So that's basically what it is. Just like you change, if you want to change something here, it will affect almost the whole system. Like from the point you tampered with down, it will affect everything. So that's basically what blockchain is all about.
Okay. Good attempt, but I think you are mixing some things up. So to get the ash part, there was a question I wanted to ask you initially, but I think I need to ask you this first. Yeah, you have a general overview, but the key detail, something is being modeled up together. So yes, the chains of blocks are being made possible through hashing, right? But the tamper-proof nature of the blockchain, yes, is made possible through hashing also. But how exactly is this done? That detail is missing. So I want you to explain it to me. We modeled it when we were using the Anders demo in the last class. So I want you to go Anders Brown's word, yeah. I want you to go into more detail on that. It's very simple, just to clarify. All right. Yeah, you have the floor, Chukwuebuka. Don't be afraid. I just want to help you clarify something. Okay?
So, from what you explained that day, I think it has to do with that model has to do with looking at. Okay, I don't want to mix it up, but what I got from that model is that when you have a block, like the blocks, they are lined up now because if we enter an information here, it produces a hash. So this hash that it will produce serves as the previous hash of a new block. So that means
Uh-huh.
that there is a connection between this particular one and this other one that is
Yeah.
being formed. And so whatever you do to change any information, it disrupts that this connection. And that's why we say that because that day I remember us seeing red, 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 red throughout. So that's how like it's called tamper proof because once you tamper it, everybody will see that it has been tampered. And it will be different from other blocks.
Exactly. So yes, that is clear now. The change of block is made possible because the hash of the previous block is included in the new block and it continues like that, like that, like that. So there's something that wasn't mentioned. So let's say you are starting a chain of blocks. Obviously, we made mention of block one, block two, block three, block four. So the first block in a blockchain, who knows what it is called? It has a name. Any idea?
Genesis block.
Exactly. So that's the genesis block. So in case you are asking that for the first block, what will be the previous hash? Obviously. So that's just like the genesis block, and to have like zero all through like that. Yes, so this is what now bets the conversation around hashing, hash functions, hashing algorithms. So this was your assignment. Who was I talking with the other time? Neo Travolta. Yes, so I want you to, you were explaining something before your network cut you off. So what I want you to do now is, there are three parts in this discussion, right? There are three parts. There is the hash itself, right? There is the hash function, and there is the hashing algorithm. So can you make an attempt to like explain these three moving parts, that are involved in the concept of hashing generally? um Can you make an attempt? Is neutral voter still here? Okay, yes. Or anybody
Mm,
else? Okay, I can hear you now.
okay. Hashing is like sealing of each block of information with a unique code, making the whole blockchain secure and tamper-proof.
Exactly. Okay.
Then hashing function helps to dictate malicious node in the blockchain. One, then two.
Wait. I don't want you to list. You've done that in assignment already, and I'm looking at it in front of me. What I want you to what I want you to just summarize basically is, what's
Okay,
the hash function? What is it doing?
the hash function helps to keep the whole blockchain in check.
Okay.
Then the third one is what? Sorry.
There's the hash function, and there's the hashing algorithm. Can you Do you understand what the hashing algorithm means, or its purpose, and all of those? Or can anybody step in for him? This was like the assignment, for the last class. It's just, this is very simple, okay? Don't let the man English get you confused.
The
All
two
right, can
part
I
is
try?
just confusing
Okay.
me.
Oh, okay. Yeah, that's the essence of what we are doing here now. Okay, so somebody wanted to say something. You can go ahead.
All right. So when we talk about hashing is just the process. That time you are changing the an input like a variable, any length into a fixed length of output. Yes, that is what hashing is. That process itself is the hashing itself. That is, it's called hashing. Now, in hash algorithm is just simply that. Sorry, okay, hash function. Before I go to hash algorithm, hash function is just like the it's just like it's an algorithm, like a mathematical algorithm itself, that ensures that this conversion of the input into a fixed output goes successfully. So it's just like, okay, now if I have, maybe I have, this is a boy. Now I want to convert it into a hash. Now the hash algorithm ensures that this conversion goes well. It is just like the mechanism itself. The hash function is the mechanism itself that ensures that this goes well. Now for the hash algorithm itself, it actually, the hash algorithm is what powers the hash function. It ensures that this hash function operates well, the way it's supposed to operate. So we have some hash algorithms that, like, because okay, I'll say that a hash algorithm determines what the hash function, how the hash function will act, and it also determines what the hashing will be like. I don't know if you guys understand.
Okay, good, very good attempt, actually. Like, very good attempt. You've gotten it right. So to break it down now, and I hope you guys are listening. So hashing, like you said, is the process of taking a value from, let's say, from what you can read or any type of value, right, to a fixed length of character, or to basically a hash value, right? So hashing is the general process, okay? The hash itself, or what they call the hash value, right, is the output of what the hash function will produce. So like you said, the hash function is basically the mechanism, right, that is used, right, to produce this fixed length, right, of value. It can be OX, it can be anything, basically, just like a the correct word to use is not encoded or encrypted actually, but I will just use it, okay? But just like an encrypted, value, right, that people can't read or you can't decode easily. So hash is the output itself, okay? Hash function is the mechanism that produces, the hash, right? Then the third part, which um is quite tricky, is the hashing algorithm. Yeah, and you made a very good attempt there, but it is not what the hashing algorithm is not basically, you can't say it's basically what is powering the hash function. No, it basically just a set of instructions, that governs the process, that the hash function will follow. So basically that it can be anything, right? And he was going there, so I'll let him continue now. So what are the different kind of algorithms that we have out there? The popular ones, and the one used in Ethereum ecosystem, and the one used in Solana ecosystem. So you have the floor. Yeah, you are killing it out there. What was it Apunash that was talking? Yeah, you have the floor. Starting to enjoy this. If you are speaking, we can't hear you. Um, um, let me check. Oh, can't hear you. Can anybody hear me?
Yes, we can hear you.
Hey,
Okay. So was it Abunash that answered that question?
Not me. I'm sorry, not me.
Oh, okay. Okay, can anybody step in? Can anybody step in? So basically what you want to do is you want to explain the hashing algorithms we have out there, and the one used in Ethereum ecosystem, the one used in Solana ecosystem, basically. Can anybody? New Travolta, wait, let me check. I think I saw something like that in your assignment. Yes, it's there. Perfect. Yes, it's there. Yeah, it's there. So anybody, or if you don't know it, just say no so I can move on. Just type.
Hello,
Okay,
hello,
okay.
sir. Uh,
I can hear
come,
you.
come again with the question. Sorry.
Okay, so the question is, now we've spoken about hashing and hashing functions and hash function itself. So now I want to talk about the algorithm. And I said the algorithm is like the set of instructions that governs how the hash function would work. You understand? Now,
Yeah.
so these hashing algorithms now, like what are they? Okay, I've explained what they are. Okay, so I want you to now talk about the different algorithms that we have out there and the ones used by Solana, yeah, and
Okay.
Ethereum,
Okay.
if you can.
All right.
But the one used in
Okay.
Solana is our focus here.
Yeah, the two major hashing algorithms are, we have the SHA-256 used on the Bitcoin blockchain, and we have the Kakek 256 used on the Ethereum blockchain. And Solana blockchain uses wow. The Solana blockchain uses SHA-256 as well. So I don't know if that answers the question.
Yes, that answers the question and it's very, very straight to the point. Yeah, good job. Good job. So anybody else, do you have any kind of contribution or okay, 5 seconds. Anybody
Okay,
with all right.
I came across some other new hash functions like Blake 3, Blake 2. Okay, Blake 3 is coming from Blake 2. And yeah, and these hash functions they have their unique characteristics. Like Blake 3 now, it helps to improve the efficiency of the blockchain in terms of ease transaction throughputs, and then it also ensures the security of the blockchain too. So, and most of these Blake 2, Blake 3, they are used in uh, they are used in newer blockchains. Sometimes you can use them in privacy blockchains too. So these are another set of hash algorithm.
Okay, yes. So that's a good one. That's a good one. And that's a unique contribution right there. Yeah, but I don't want us to just stand on general overview. Okay. I I want us to like delve into the whys and the reasons why things are the way they are. So the problem is not enough algorithms, right? The problem is not that there are not enough algorithms, because I can go on and on and on to tell you different types. Okay, so the popular type of algorithms we have them in families. So there is no just one type of, they are usually in like families, and I can explain to you why they are like that, but not now. But so he mentioned Blake 3, right? And he said Blake 3 comes from Blake 2. We also have SHA, right, which means secure hashing algorithm. Now is that, if you remember when I was explaining hashing, right, I gave you some characteristics. I pasted it in the chat. I'm sure nobody copied it, right? There are some characteristics that a good or a quality hashing algorithm must have. I'll not mention everything, obviously, but the major one, right, out of all of them is that a hashing algorithm ah Oh, should I say this? Should I say this? I hope it's not too much for your head, but I'll just simplify it also. It must be like collision resistant. So this means that when for you to know that a hashing algorithm is effective, it must not at any time produce the same output for two different type of values. Do you understand? So even if we have a billion, number of variables of values, no two value, right, must be the same. And that's the problem with all of these different hashing algorithms that we have out there. You would have heard of something they call brute force, right? Or brute force attack. Like brute force is everywhere. It's in web 2, it's in web 3. So you can use brute force to hack a phone. You can use brute force to hack your passport. What brute force means is you are just guessing randomly at a heavy pace. So that's why they tell you guys not to use your name, right, for password and everything. Because if my name is Mide and my my email password is midday 1949 full stop, something like that. A hacker will just get dis random values and start guessing, try midday with a lot of numbers, and it just takes 1949 attempts, right, for him to get my correct password. So that's what they call like brute force. Then I know I'm already going too far, but the basic idea is the problem is not that there are not enough algorithms, but but the main thing that is important is that the hashing algorithm must be secure enough and must possess the important quality, that it must be collision resistant, that at no time no hashing algorithm, right, should produce the same output for two different type of values. So it is impossible for you to get the same hash for two different inputs. That's basically what it is doing, or what it is saying. So this is why, and this is why I was explaining this in the first place. This is why you see that everywhere you turn to, you either see SHA or KECAC, because these algorithms have been tested over time, right? And um it has been standardized, right, that this type of algorithms, right, have survived that test. Do you understand? So in Bitcoin, right, Bitcoin, when it was created in 2000, and obviously it should have been built before 2009, but when it was released in 2009 to the public, um it went with the SHA 256 hashing algorithm. Why? Because SHA-256 was the approved and conventional standard at that time. Do you understand? So when if you go to the whole computer mathematical world and they were like, okay, we need an algorithm, right, to power our hash functions in the Bitcoin space, which one do we use? They needed an algorithm that is secure and has passed these 5 tests. I don't want to mention the 5 because I pasted it in last class, but if you want me to, I will. Right, but just know that the important one is that it must be collision resistant and everything. So that's why when Ethereum was created in 2015, right, the industry tilted towards um KCAC 256. There's also a long history behind that, right, which came out from a hackathon put by SHA also, and KCAC was the new standard, also called SHA3 or SHA3, right? SHA-256 belongs to SHA-2 family and everything. But KECAC was the standard at the time Ethereum was created, right, in 2015. So Solana also went with SHA-256 also. So that's just like giving you some theoretical understanding. Wait, do you guys understand everything I've been explaining so far?
Yes, most will be necessary, not all.
Alright. I'm not usually the theory kind of person, but I just have to do this one for you guys so you can just understand some things. So moving away from hashing, because we need to wrap this up before 8 p.m. We spoke about smart contracts and everything, smart contracts. So who can give us like an overview of what you understand by smart contracts? What do you think they mean? What do they do? You know, can anybody, let me see. What did we discuss in the last class? Yeah, but it's just smart contracts. Their use, challenges, limitations. But basically, I want to know how you understand smart contracts. You don't need to read the definition or anything. Just explain what you know a smart contract is all about.
Hello, can you hear me?
Yes, I can.
Uh, Smart contract, basically, from my own understanding, is like a program being deployed on a particular machine or blockchain that when certain commands are being met, it will execute on its own without waiting for third party. Uh, oh my God. And smart contracts must be. Shit. So that's all I.
Is it only me? I think you are breaking, so I missed some
Hear
words.
me?
Yes, I can hear you now.
Okay, smart contract is like uh, codes or program being deployed on a particular machine in a blockchain that when certain criteria are being met, it will execute on its own without waiting for third parties.
Yes, that's correct. Yes, that's correct. Yes, that's correct. Good one. That's a good attempt. Yeah, at least. That's basically what a smart contract is doing in the general summary. So, in your classes with other tutors, have you guys started writing code and all of those things?
We have started with as I told you.
Okay. So have you started writing smart contracts?
At the moment, we are we are using the Solana playground to familiarize ourselves with how to build and deploy codes. Hello, can you hear me? It's like the network generally is not stable.
Yeah, I think so. Can you hear me?
Yes,
Yes,
I
I
can
can hear
hear
you.
you.
Oh,
Did you hear
Okay.
what I said earlier?
Yes, I heard you. I heard you.
Mm.
Okay. So that's a good one. I would have loved to like teach you guys, EVM kind of things, but we need to keep the focus focused. So yes, you guys be writing your smart contracts on Solana blockchain through Rust and all of those things. Yes, so the reason why I asked that question is because during your building phase, right, you would notice the three or the major qualities of a smart contract, right? It is first that it is self executable, right? It executes on its own, and that's what was it Abunash or who answered that question? That was what he explained perfectly. Then the second is that it is immutable, right? It is immutable. So once you deploy it on a blockchain, it cannot be changed basically. So once you deploy it on a blockchain, it cannot be changed. That's the whole gist around smart contract. I just realized that it was a different what was it called? It was a different what do we call these things that we are doing? It's a boot camp, yeah. It was a different boot camp I gave my definition of smart contract. Sorry guys, I'm not a lecturer or anything like that oh. I dey write code too, but I just like explaining things to people. I'm looking for the particular definition I give so I can share it with you guys also. So if you need to go for talks, they invite you to come and give a talk or a speech on, or you are invited to a professional gathering and you are talking to investors on, you are trying to sell the idea of smart contracts to them, those are the questions they will ask. So if my eyes can open well and I see, um okay, I think I'm about to find it now. Okay, so who can just give us the type of things we can build with smart contracts? Just give me examples of what we can build with smart contracts. Anybody? um
Do you mean the logic that will require a smart contract, or a transaction that will require a smart contract?
No, any type of app you can build, using smart contracts.
Okay.
Hello.
Yes, I can hear you.
You can build a decentralized application with a smart contract,
um
even a metaverse application with a smart contract, a gamified application with a smart contract. Virtually, you can build almost everything with smart contracts because the blockchain has made it very easy for us these days. So that's it.
Alright. So in the last class we discussed some limitations and problems around building applications with smart contract, and these are some of
Yes.
the issues, that are making the growth of blockchain, on the mainstream level, making it slow down and all of these things. So can you recollect any of these problems? Can you recollect any of them? Oh, okay. So I gave you some of them. I said, one of the problems with smart contracts is that, its immutability, as much as it is a strength, right, is one of its major weaknesses. The fact that it doesn't give you flexibility, right? Once you deploy a smart contract on the blockchain, right, you cannot edit it, right? You cannot edit that smart contract. You cannot edit the smart contract, and that is like a problem for most use cases. Because I can take example from banks, right? So if a bank was to run their entire operation on the blockchain, we are now saying that whatever, right, the bank wants to do, right, it needs to predict the entire future, right, its entire future, right, and deploy it at once. The problem now is that once it deploys it and something changes, right, if something, should change in the future, right, they can't go back, right, to change that type of thing. So these big companies especially that like to be dynamic with the tides of the market and everything, because they need dynamism to survive, right, they don't embrace smart contracts because of its rigidity. So that's one thing you always want to bear in mind. You also spoke passively about regulation, right? There are no laws basically that govern smart contracts. So everybody basically, if I use the slang, right, that was trending, I think 2021 or thereabout, everybody, all Web3 developers, we are basically just turning on our own, right? We are doing things as we please. No law, no well-defined authority saying these are the limits and extent of what we can do. And that's a big problem, because tomorrow the police can decide to just arrest somebody without any base, and you yourself, right, you can't argue anything. It happened to a particular Okay, it happened to a particular developer, right? I said this in the last class. Okay, so in summary, right, I did not find this definition, but in summary, right, the three major characteristics of a smart contract. Yeah, I'm not saying it is finite, because you people can add, but the three primary characteristics is the self-executory, it is decentralized, and it is immutable. Right, so, and if the code is verified and all, it's also transparent. But just bear in mind that people are now devising means to make smart contracts editable in form of upgradable smart contracts and all of those things. So I have covered everything. Do you guys have any question, right, before we end the class? Is there
Sorry,
any question?
sir, I have one question, please. Can you hear me?
Yes, I can hear you.
Okay. What's the difference between smart contract and a contract address?
Okay, what question do you want to ask?
Like, you didn't get my question. Can you hear me now?
Yes, I can hear you.
What's the difference between a smart contract and a contract address?
Oh, that's a good question. That's a good question. Um, yes. So if you remember when I think, was it our first class or second class, when we were talking about web two and web3, right? The differences between web two. Okay, guys, the class, question, just I wasn't looking at the screen when you asked. I just want to do something. Who asked the question? Um, okay. I'll just continue then. Okay, so if you want to say if GameFi Queen wants to do what's it called? If she wants to do a party, for instance, now, she hits a $1.5 million contract, and she wants to throw, a party like that. So what's the first thing you ask? Okay, where is the party, right? And she will give you address. Okay, we are doing it at top floor in Houston, or whatever destination party that you want to do. So you are going to need that address. So with the address, you can go to the exact location where that party is going to, where it's going to be held. So now this is the same thing. It's the same thing with a contract address. We have a contract that we've written and we've put it somewhere on the blockchain. Now, if you want to access that contract, you are going to need the address. So the same way www.google.com will take you to Google's website, that address will take you to where that contract is on the blockchain. You can now see the contract, interact with it, and do whatever you want to do with it. So that's basically what the contract address means, leading you to that particular contract on the blockchain. It's called a contract, right? So the address of that contract. That's why if you want to buy a token in Solana, for instance, you will need the CA. like the gen people call it, like contract address. So with that contract address, if you paste it on a platform like Dex Screener or Jupiter Swap, Jupiter Swap will now get the address and look for the particular pool or wherever where the token is, right? And just, okay, this is the token this person wants to buy. This is it, right? And can interact with it. Do you understand? That's basically what a contract address means. It's not just like your normal, this normal way it works in Web2. So do you have any other question? You can ask me any question, even outside, what I've taught you
Yes,
also.
yes. I have a second question. Sorry.
Okay, go on.
Why is it that after deploying a smart contract on a particular blockchain, using that same contract address, you can't find that contract on a different blockchain?
Exactly. So that is the example I was giving you. So
Okay. Okay.
okay, don't let me use this example I wanted to give. The example I wanted to give you was basically like in the normal world. So if I build my house now, right, in Lagos, obviously, if you want to access the house, you can only see the house in Lagos where I built it, right? That's just like the basic, but it's not so smart of an example, but that's just like the basic example. So that's the same way it works in the blockchain. So you see these things we call blockchains, right? Most of them are just virtual machines, that operate on a decentralized network of nodes. You already know what that means, right? So a blockchain, right, is like its own ecosystem, right? It is its own world entirely. So if you deploy an application on Solana, right, in its own world, if you build your house in Jupiter now or in Mars, that's where everybody is going now. If you build your house in Mars, you cannot find it in Earth, right? Because that's another ecosystem on its own. So that's the same way it works. Do you understand? Do you understand my example? Um, you are unmuted, but I can't still hear you. Yes, yes. I said, do you understand the explanation I just gave you?
Yes, sir. Thank you for that.
All right. So, any other question? Being within or outside the scope of what I've taught you? Because I think this is my last class based on what the instructors told me this evening with you guys. So, feel free to ask whatever question you want to ask.
I have a question.
All right.
If
The first
yeah,
one.
um,
Yes. How long does it take for a block to get failed and then the next block?
Wait, sorry, I can't hear you. I can only hear you faintly.
Yes. I'm asking like how many minutes does a block take to close and then another block opens in the blockchain?
Okay. Did you say how long does it take to close a transaction?
A block, a block on a blockchain.
Okay. Wait. I don't think I got your question correct. Can you take it again?
Yeah. So my
Okay.
question here is that when a block starts to accumulate data, I'm talking about transactions and
Oh,
so how
okay,
long
okay.
does it take to get filled up, create a hash, and then continues in the next block?
Oh, okay. Yes, that question is relative because it depends on there's something they call the block size, right? It depends on the size of the block. Do you understand? Depends on the size of the block. So I think for Ethereum, I'm not very much familiar with Solana. I don't do core level development on Solana, but I think for Ethereum, the size is about 12 MB or something like that. So each block, right, has its own size. So it's the answer to that question is it depends on how many transactions it takes, right, to fill in that block. Do you understand? So once that block is filled with enough data and it can't take more another data or something, the block is closed and then a new one is created.
I understand now. Thank you.
Do you understand?
I understand.
Yeah. So do you have any other question?
Okay. According to, I was just trying to find out why, like, okay, let's look at BNB. Sometimes they have this different, okay, BNB on this network, BNB on the other network. I'm trying to look at, is it because when they deploy to blockchain is immutable? Is that the reason why they are creating different different?
Okay, why you having like the same token on different networks, right?
Yes, sir.
Okay, that's a good question. And the answer is almost the same answer to the question, that I think New Travolta asked. That why is it that when you deploy a contract on only Solana now, you can only find it on Solana. So what you need to understand, that reason is more of related to human behaviour or consumer need than the technical reason. So it's because, like I said, dis blockchains are like ecosystems, that people live in. People have their own preference and everything, right? So for instance now, for Ethereum, right, some people prefer to use Ethereum. They would rather go broke than for them to go to Solana, right? No. The reason is everybody has their own reason. For instance now, for Ethereum, some of them were no, for Bitcoin for instance, some of them were there. They were like at the beginning of the whole Bitcoin growth, and as a result they become like a Bitcoin maxi, like they call themselves. So they would not buy any other token apart from Bitcoin. For Ethereum now, they have like something they call like a community. Ethereum has its own community, right? And even though gas fees are high, there are a lot of top level investors, like people with big money, big liquidity, right, that live on Ethereum, right? Not that they live there physically, but they put their money, right, on Ethereum. So they will tell you that they are not going to put their money on any other blockchain. Why? Because probably they feel that Ethereum is more secure than any other blockchain. If you check Polygon has like a lot of Indians, because that's the community. A lot of, I don't know, is it not Asians per se, but we have this community of people on Polygon also. Then Binance Smart Chain, right, has a lot of Asians, right, because obviously it started from that their region. So these different blockchains have their own ecosystem with their own community. So me as a project now, right, I don't want to limit myself. I don't want to limit myself to just one place. I want to, okay, I say, okay, I want people to buy this my token, and I want to make it available on these different blockchains that they already have their money on. So instead of trying to convince a Ethereum maxi now that, okay, I have this project on BSC, bring your money from Ethereum to BSC to come and buy. He will tell you that, no, I'm not comfortable with BSC, I do all my stuffs on Ethereum. So you don't want to lose that kind of investor. So what a project owner, and I'm saying this because I recently did this for a project, right? We deployed the same token on Ethereum and Polygon. Ethereum to win the hearts of these big investors, and Polygon for people who can't afford the gas fee. So these are like the reasons. So you see BNB now, because they want to be everywhere, they deploy on every blockchain that is EVM compatible. So that's just the reason. It's more of a human consumer, having the consumer, or what is called the end user in mind, than a technical reason. Do you understand?
Yes, sir. If since they are deploying on different networks, sir, is it going to affect the price at the long run?
That's something else entirely. So for price is determined by what is it called, demand and supply, like you already know. So price management, goes along with something called like liquidity management. So for price, you have to like have solid blockchain or token economics, what they call tokenomics, right? You have to have like someone who is versatile in that knowledge. So you can have your tokens on different blockchains, right? You just have to have good liquidity management, right, on these different blockchains. So that's just something like that. So if you just make sure that you're having like enough liquidity on blockchain, on Bitcoin, sorry, on Ethereum, BSC, Polygon, Arbitrum, Optimism, all these chains like that. So it takes some knowledge of liquidity management and the economic side of things. So once again, it's not really like a technical thing, it's more of like an economics puzzle. Do you understand?
Yeah, thank you, sir.
Alright guys, do you have any other question? I don't know, I've not, okay, I've heard from New Travolta, I've heard from Raymond. Okay. Is that all before we end the class? Um okay. In the okay, does someone want to say something? In the absence of no question, thank you guys for staying to the end, right, of this particular class. That's 1 hour 13 minutes. This is my last class with you guys. Mine was to lay the foundation, right, for all the technical concept and or theoretical concept. So you'll be going deep into practicing these different concepts that we've mentioned. When you start encrypting data, right, you'll be encrypting them using hashing and all of those things. Yes, so I wish you guys all the very best, right? So I don't know if you guys, like, I'm on the group, so if you ever want to ask any other question, just tag me or something. I should be able to see it. Even though my telegram is jam-packed. God have mercy. So guys, take care of yourself, right? And thank you for staying till the end of the class.
Thank you, sir. Thank you for the
Thank you,
class.
sir.
Yeah.